So in this video we're going to look at partial fraction decomposition when we've got a cubic polynomial in the denominator. So here we've got this x cubed polynomial here, so minus x squared plus 17x minus 10. Now the numerator is already taken care of. We've got two factors here and we've got this constant added on to this. So how are we going to handle this denominator? Well, first of all, we need to try and find a factor of that, and then maybe we've got a nice quadratic we can work with at the end of that result. So just looking at that quickly, if we plug in 0 for x, that's not going to work because we just end up with minus 10. So let's try plugging in 1. So if we plug in 1, 1 cubed is 1. Minus 8 times 1 squared is minus 8. 17 times 1 plus 17. And minus 10. So 1 plus 17 is 18. Minus 8 minus 10 minus 18. So therefore x minus 1 is a factor. So we could take an x minus 1 out of it. So let's have a go at that. Okay, let's take that bit off the board. Okay, so now we're going to take x minus 1 out of this cubic polynomial here. Now there's a couple of ways we can do it. We can do polynomial long division, which is one I recommend you have a go at. And another way we can do this is synthetic division. So for this question here, I'm going to do synthetic division. So there's a little setup we need to do first. So first of all, I set up a nice box and I write my variables with their indices over the top. So I've got x cubes, x squareds, x and constants. And I write my factor, which is here is x minus 1, which means 1 is a factor. So I'll put in here a 1. So I'll put that at the side. And then I set up all the coefficients of the corresponding variables in a line up here. So x cubed has got a 1, x squared has got a minus 8, x has got a 17, and the constant is minus 10. Okay, now the first thing I do is I put in a box here, I put a 0. So set that up first. So this box underneath is just going to be my remainders. It's going to be help me out with my working. My result is going to appear inside the box. Okay. So what I do is I put a plus sign here and then I add these two results together and stick them in the bottom of this line here corresponding to my remainders to help me with my working. So 1 plus 0 is 1. So now what I do is I do 1 times 1, which gives me 1, and I put that result inside here. And then I add these two terms here, minus 8 plus 1, which gives me minus 7. Okay. Now this minus 7 here, my remainder here, I now use that and multiply it with this factor. So 1 times minus 7 is minus 7. And I put the result in the next box. Okay, so now I've got to add again. So now I'll go to the x column, 17 and minus 7. That gives me positive 10. And now this remainder I'll multiply with this 1. So 1 times 10 is 10. And then all being well, we get a 0 at the end. Minus 10 plus 10 gives me 0. Okay, right. So now what I get is the result is these terms in here. Now these correspond to the coefficients of the quadratic when I've taken x minus 1 out of here. So now what I can do is I can rewrite this as x minus 1, and then I've got here x squared minus 7x and plus 10 for my constant. Okay, so that's the result of my synthetic division. Okay, let's take this off the board and let's continue to work with this. Okay, so that's the result of my synthetic division in the box. So now let's work with this and see if we can break this apart even more. So we've got a positive 10 here and a minus 7x here. So I can see straight away factors of 10 are 5 and 2. And if they're both minuses, I'll get a minus 7. So I can break this down again even more into x minus 5, x minus 2. Minus 5 times minus 2 gives me plus 10. Minus 5x and a minus 2x, minus 7x, x squared. So I'm happy with that. Okay, so now what I can do is now I can rewrite this with these factors taken out of this. And then we can see what we do for partial fractions. Okay, so now we've got this all factored out in our denominator. We're ready now to do partial fraction decomposition and do our setup. So our setup for this can be, we can write this equation here, and it equals some constant a over this factor, so that's x minus 1. And then we've got this one here, x minus 2. So we need another constant now, b over x minus 2. And then break this one out of it, x minus 5. So we need another constant, c x minus 5. Now these constants are all to be found by breaking this apart. So what we can do here, as we've got all different factors of these three in the denominator, we can use the Heaviside cover-up method. So if I take a 1 in here, this one will cover up. Put a 2 in, this one will cover up. And a 5 in here, this one will cover up. If we had similar factors, we couldn't use this technique. So, right, let's do a little setup for this, and we'll use a Heaviside cover-up method. So I'm going to rewrite this fraction here, and then what we can do is plug in each of the values and see what we get. Okay, so now we've got our setup ready for the Heaviside cover-up method. Let's start off first of all with an x equals 1. If x equals 1, this one will disappear, and then plug in 1 into all of these, and it will give us our value for our coefficient of a. So let's go straight into that. So when x equals 1, here I've got 3 plus 1 minus 2, 2 times 1 minus 9, and then denominator, this one disappears, so just plug a 1 into these. So I've got 1 minus 2 and 1 minus 5. Okay, let's just quickly solve these off in the brackets. 1 minus 2 is minus 1. 2 minus 9 is minus 7. Here we've got a minus 1. Here we've got minus 4. Okay, minus 1 times minus 7, that's going to give me 7. Minus 1 times minus 4, that's going to give me positive 4. Okay, 3 plus the 7 gives me 10. 10 over 4 gives me 5 over 2. So therefore my a is 5 over 2. So let's just write that up over there. Okay, right. Let's have a look now for when x equals 2. Let's do that one over here. Okay, x equals 2. Let's plug that into here, same way we did here. This time this one will disappear. So x equals 2. So we've got now 3 plus 2 minus 2. Now notice this one's in the numerator. That one turns into a 0. It just doesn't disappear. We still have to use it. So here we've got a 2 times 2 minus 9. And then denominator 2 minus 1 and 2 minus 5. Okay, let's work out the bracket ones. 2 minus 1 is 1. 2 minus 5 minus 3. And then here this is a 0. So whatever that is, that's going to disappear. So this whole thing disappears to 0. 1 times minus 3, this just becomes minus 3. Okay, so now we've got a 3 divided by minus 3, which gives me minus 1. So therefore b is minus 1. Okay, right, let's have a look at when x equals 5. Okay, let's put that one down here. X equals 5. So what we're going to do now, plug in 5 for all of this again. This time this one will cover up. So now I've got 3 plus 5 minus 2. 2 times 5 minus 9. And then divide that by 5 minus 1 and 5 minus 2. Okay, right. Let's work out in the brackets. 5 minus 2, that gives me 3. 2 times 5 minus 9, well 2 5s are 10, minus 9 just gives me 1. Okay, so 3 plus 3, that's going to give me 6. And then here, 5 minus 1 is 4, 5 minus 2 is 3, 4 3s, that's going to give me 12. So therefore, my coefficient for C is 1/2. Okay, so now I've worked out all my coefficients, I'm now ready to put in my answer for my partial fraction decomposition. Okay, so A is 5 over 2. So I can write that as 5 over 2 times x minus 1. So that takes care of this term. Now I've got my x minus 2, so my b is minus 1. So instead of a plus, I'll just put a minus. So minus 1 over x minus 2. So minus 1 over x minus 2. So that would take care of that one. And then my c coefficient is a half. So I've just changed the c on the numerator to a 1. Notice that it's positive, and it's 2 times x minus 5. That's how I get my half in there. Okay, that's my partial fraction decomposition of this term here. So this f of x then turns into that after partial fraction decomposition. Okay,